All right, so let's talk about the diagonal positions. So with the diagonal position, you're going to have to check a 4 by 4 grid for the target pattern instead of just like, a vertical row or two horizontal rows. So it gets to be a little bit more complicated, but it's the same exact kind of methodology that at least I think you should employ when you're looking for these positions. So here the blue represents filled, although these it's implied that these are filled if anything above it is filled, um, it's implied that it's filled. So in fact, we just don't care about what the values are underneath things that are filled, but just to be clear, I don't know if this is clear or the other way is clear. These are the only positions that we care about for this diagonal pattern. So we need to know that this one is filled, so there's somewhere for it to rest on, and that this one is open, and that these three are the color that we're looking for, either red or yellow, the piece color, and we send it both, red or yellow. In either case, we know that we need to go here, because either we're going to win or they're going to win if we don't go here. And then you do have to check that B, G, and L are open, in this position. Or no, you don't have to check if those three are open. You only have to check if this one's open. I'm sorry, that was a mistake. So anyway, you just have to look for only the important information. You'll still want to set up, though, these variables, I think, so that you can just easily kind of refer to them rather than having to type like originating row plus 0, originating call plus 0, originating row plus 1, originating call plus 1. It's just annoying to have to write that all the time. So just give them names, and it's, I think, easiest just to name them these single letters so that you can just quickly reference the locations. It's also important to have diagrams denoting what those things are. So anyway, the red is still the bounding box in this case for the row and column loops, so that we don't go out of bounds in those situations. And then, this is the pattern that you want to look for. There's another pattern, obviously, where this one would be closed, and then this one would be open, or that we just wouldn't care about it. And then this one would be open, and this one would have to be filled with either color. So there's this pattern, then there's the reverse of the diagonal with all of those different patterns that you'd have to check for. And then, more advanced strategy is that you would want to check for creating win positions, and I'll describe those, or you can look those up, frankly. I'm going to leave that to you to kind of look it up, but the basic win strategy for Connect 4 is to create a situation in which you have forked wins. So you create a situation where your opponent either has to provide you with a win or cannot block both your wins. And there are some very strong positions that you can train your computer program to look for and to create. But it will take, quite long algorithms to do that. So you'll have to kind of think about looking for patterns, and in which cases do we, think move or 2 or 3 out even to create a really strong computer player. So with that, I think I'll kind of leave it to you guys to try and come up with strategies by which you can, create a program that's smart. Best of luck.